This question involves finding the area of a sector of a circle, and in that process we will be using the cosine rule. The question is taken from the Core Book Maths worksheet cosine rule apply section, and it is question 5. The two formula we will use is the cosine rule, which is here, a squared equals b squared plus c squared minus 2bc cos a. The thing to remember is that the angles are written in uppercase, the sides are written in lowercase, and the lowercase is opposite its corresponding letter. This question also involves the formula for the area of a sector of a circle. So area of a circle, as you know, is pi times radius squared. For a sector, it is simply pi times radius squared multiplied by the fraction of the circle that you're using. So if the angle is theta, then we want theta divided by 360, 360 being the complete circle, multiplied by pi r squared. So here's our question. We have the sector of a circle OAB. The diagram is labelled 9 centimeters for the radius, 10.35 for the length of the chord. We want to find the area. I can put another measurement onto my diagram, so I'll do that straight away, which is this measurement OB, and that is also 9 centimeters. And I know to find the area of a sector, I need to know the angle of the sector. I need to find this angle here. I'm going to call that theta. So I need to find that angle. Once I know the angle, I can calculate the area. So just looking at the triangle then, I have triangle AOB. So that's this triangle here. I want to find this angle, theta. That's O, that's A, that's B. I know the three sides. These measurements are in centimeters. So with three sides, I can put it into the cosine formula and solve for the angle. So let's do that. Now, just looking at the formula, I have a squared equals b squared plus c squared minus 2bc cos a. Don't get confused by the letters. The diagram is labelled OAC, but my little triangle here, the important thing is this angle here corresponds to this side here. So my angle is theta. So this angle here is going to be theta. The opposite side then, A, is going to be 10.35. And that's what 10.35 squared. The other two sides are interchangeable, B and C. Let's put them into the formula. I have 10.35 squared equals 9 squared plus 9 squared minus 2 times 9 times 9 times the cosine of theta. Let's tidy that up. I've got 10.35 squared is equal to 162 minus 162 cosine of theta. Let's bring the cosine term to the left-hand side. That will make it positive. So I have 162 cos theta. So I've added that to both sides. I'm going to take away at the same time 10.35 squared. So I have 162 take away 10.35 squared. So just to recap, I added this to both sides and I subtracted this from both sides at the same time. If I tidy that up, then my right hand side will become 54.8775, and that's 162 cos theta. So cos theta will be that 54.8775 divided by 162. So theta will be cos to the minus 1 of that value of 54.8775 over 162. Let's move this up. So theta then works out, if you put that into your calculator, works out to be 70.20. I'm going to go to 2 decimal places for this. 72.20 degrees. Now I have my angle. I can now use my formula for the area of a sector. So my area is my angle, which is 70.20 divided by 360, which would be for a complete circle, multiplied by pi, multiplied by the radius, which is 9, and that's squared. Put all that into a calculator, and then I get the answer for the area of 49.62 centimeters squared.